In this video, I'm going to be going through the Chapter 9, Test 1, Solving Quadratic Equations homework review, the back side of that. Okay, so again, we have this first problem here. I think through my flow chart, first thing I notice is that it's set equal to 0, so that's a good start. So next I'm going to look to see if I can factor it. All right. It doesn't look easily factorable because a isn't 1. So I can't just do big X method. So I'm going to go ahead and skip that. I'm not going to factor because it doesn't look like I could do it easily. Second thing I look for is, am I missing the middle b term? I'm not. Okay, I'm not missing that. So I can't do square root method. So the only thing that's left would be completing the square quadratic formula. And like I said in the last video, I personally, if I had to pick between these two, would just go ahead and just do go straight into doing quadratic formula, because quadratic formula works on every problem. And I think it's easier than completing the square. So let's go ahead and just go straight here. Another hint I would say is that anytime you have a trinomial here on the left-hand side and a is not 1, I would just automatically go straight into quadratic formula. So for this problem, a is 4, b is 4, and c is -1. Okay, and I'm doing quadratic formula. So I'm going to first find the discriminant. So I have b squared minus 4ac. B squared would be 4 squared minus 4 times -1. 4 squared would be 16 minus 4 times 4 is 16 times -1. This would be plus 16. So 32. So my discriminant would be 32. Now I'm going to complete my quadratic formula here. X equals negative b, which is 4, plus or minus the square root of 32, which I just found above, all over 2 times a, which in this case is 4. So I have -4 plus or minus 5.66, if you round it, all over 8. So I have -4 plus 5.66 divided by 8. And -4 minus 5.66 divided by 8. So I have these two expressions to solve here, these two equations. And when you solve those, just type them in your calculator, you should get 0.21 and -1.21. Okay, for number 8. First thing I noticed is that it's set equal to 0, so that's a good start. Okay, I'm going to look to see if I can factor this first. It does look like it's factorable. It has a GCF of 8x. 8 goes into both of these, and they both have an x in common. So I'm going to factor out a GCF of 8x and see what happens. 16x squared divided by 8x is 2x. -24x divided by 8x is -3. Okay, I can't factor it any further. This factored nicely here for us, so let's go ahead and do factoring method. So I'm going to take each factor, set them both equal to 0. 8x equals 0 and 2x minus 3 equals 0. I'm going to solve both of those. So for this one, I'll divide both sides by 8. For this one, it's a two-step equation, so I'm going to add the constant over first, then divide both sides by 2. And so I get 0 and 3/2. So which method did I use here? I used factoring method. And why did I use that? Because you can easily factor. Okay, the next problem, first thing I have to do is get it in the correct format. So I need to move this 3x over and the 1 over. So I'm going to subtract them from both sides. And when I do that, I'll now have this. So I move the 3x over by subtracting it. I move the 1 over by subtracting it. And then now I have the correct format equals 0. Like I was saying a minute ago, if I have a trinomial and a is not 1, I'm going to go ahead and just automatically do quadratic formula. A is 2, b is -3, and c is -1. I'm going to find the discriminant. So b squared minus 4ac. B squared would be -3 squared minus 4 times a, which is 2, times c, which is -1. -3 squared is 9. Negative 4 times 2 times negative 1 would be positive 8. So that's 17. So my discriminant is 17. So I have x equals negative b, and b is negative 3, plus or minus the square root of 17 all over 2 times a, which is 2. So I really have, that's a positive 3 now. Plus or minus the square root of 17 is 4.12 all over 4. Not just going to stop there. I'm going to go ahead and solve these. So 3 plus 4.12 divided by 4 and 3 minus 4.12 divided by 4. And then when you solve both of those, you should get 1.78 and negative 0.28. Okay, for the next problem, it's set equal to 0, so that's a good start. First thing I'm going to look to do is see if I can factor it. I'll do my big X method because it's a trinomial and a is equal to 1. So a times c on top, b on the bottom. A times c is 1 times 6, which is 6. B is negative 5. The two numbers that multiply to be 6 and add to be negative 5 are negative 3 and negative 2. So that does factor. I have x minus 3 and x minus 2 equals 0. I said each of the factors equal to 0. And I solved them. So I get 3 and 2. That one was factoring method. For the next one, first thing I noticed is that even though it's not set equal to 0, that's okay. Because if you notice, we have a squared term, we have a quadratic term, we have a constant, and we have a constant, which means we're missing that linear bx term in the middle, the term with just an x to the first power. So we're missing that, so that's how we know we're going to do square root method. Square root method. So that's what I'm going to do, and to start that, I'm going to isolate the x squared by adding 2 to both sides. So 1/3 x squared is equal to 6. To get rid of this fractional coefficient, I'm going to multiply by the reciprocal, which is 3. So I have x squared is equal to 18. Now that the x squared is isolated, I'm going to take the square root of both sides. The square root of 18 is positive or negative 4.24. Okay, which means x equals positive 4.24 and x equals negative 4.24. Okay, for the next problem, first thing I'm going to do, since I have all the terms I need, a quadratic term, a linear term, and a constant term, is I'm going to move this 10 over to make this equal to 0. So I have 3x squared plus x minus 10 equals 0. Again, like I was saying earlier, there are other methods you could probably use here. I know factoring would work, but like I was saying, if you have a trinomial and a is not equal to 1, just go ahead and do quadratic formula. Okay, because if you do factor that, which you can, you'd have to do split the middle, which is a little bit of work, about the same amount as quadratic formula. So honestly, it's completely up to you. You could factor or split the middle, but I'm going to do quadratic formula instead. So first I'm going to find the discriminant. B squared minus 4ac would be 1 squared minus 4 times a times c. 1 squared is 1. Negative 4 times 3 is negative 12 times 100 would be positive 120, which would be 121. This is a perfect number. So our equation here will actually come out to be pretty nice. So x equals negative b plus or minus the square root of 121 all over 2a. So this is negative 1 plus or minus the square root of 121 is 11 all over 6. Now, like I was saying, this is a perfect number, so it came out nicely. If this comes out nice like this, that means the original equation was factorable, which I already mentioned. So you could have factored if you wanted. So I'm going to have negative 1 plus 11 divided by 6 and negative 1 minus 11 divided by 6. Okay, well, negative 1 plus 11, would be 10 over 6, which is really just 5/3. And then -1 over -11 would be -12 over 6, which is -2. And I apologize, it's a little tiny there, but 5/3 and -2 would be your answers. Okay, for number 13, okay, it's set equal to 0. You could factor that. It is factorable, but I think typically, and we should get in the mindset of thinking this, once I see a squared term and a constant, no linear bx term, I'm going to do square root method. But you could factor that if you wanted. So I'm going to isolate the x squared. So I'm going to add 49 to both sides. Divide both sides by 9. Okay, once I have the x squared isolated, I'm going to square root both sides. Now, we haven't done an example like this, I don't believe, but what you're going to do is if you have a fraction underneath your square root symbol, you're just going to take the square root of each piece. So you're going to take the square root of the top and the square root of the bottom. And then remember, when we take the square root, we include our positive negative sign. So the square root of 49 is 7, and the square root of 9 is 3. So I have positive or negative 7/3. So positive 7/3 and negative 7/3 would be the answer. And you get the same answer if you did factoring method as well. For 14, I'm also going to do square root method because it has this grouping symbol that's set of parentheses squared. I'm going to isolate that by dividing both sides by 2. So I have x minus 6 squared equals 16. Now that I have that squared piece isolated, I'm going to take the square root of both sides. The square root of x minus 6 squared is x minus 6. The square root of 16 is positive or negative 4. So I have x minus 6 equals 4 and x minus 6 equals negative 4. I solve both of these. And I get 10 and 2. For the last problem, this one's pretty straightforward. It's already in factored form for us, so we're going to use factoring method. So I'm just going to take each factor, set them both equal to 0. So for this first one, I add 4 to both sides, then I divide both sides by 5, and I get 4/5. For the second one, I'm going to subtract 1 from both sides. Divide both sides by 2, so x is negative 1/2. All right, we've made it to the end of the review, so great work on that. And if you have any questions, please reach out.